All right, everyone, welcome back to Calculus 3. So in this video, we are going to talk about 5.5 triple integrals in cylindrical and spherical coordinates, but we are going to just utilize the triple integral to convert from the rectangular coordinate to cylindrical coordinates. So it might be something very similar what we learned in the double integral. So I will talk about that soon. And then if we finish, I might be moving to 5.6. So let's just see how much we can finish 5.5 and 5.6 today. It's going to be very short topic for each. So these are the last two units in chapter 5. And then, yep, that's pretty good. So let me introduce 5.5, the cylindrical coordinate system. So here we go. So a little bit of background. In earlier, I show you how to convert a double integral in rectangular coordinates into a double integral in polar coordinates whenever you are dealing with the problem in the region and volume. Do you guys remember that? So now we are doing the same thing in this section. We're just going to convert triple integral because we're going to deal with three variables of the function. So we are going to convert triple integrals in rectangular coordinates into triple integral in cylindrical coordinates. So let me just write down a little bit of background. In double integral, we used to change to the polar coordinate system. So this is the rectangular coordinates. And then, if you have a complicated an x and y interval, we can convert it to the polar coordinate system, if you remember that. So at that time, we had a two variable xy or r theta in each different coordinate system. So now we are doing the same thing, just the name. It's a little bit different. So we have, let's say now we are dealing with the three variable. So that's why we have a triple integral, because you have to find out each interval for x, y, z. And then you might want to convert to polar coordinate system, but in three variable, we call r theta z. We call this as a cylindrical coordinate system instead of saying polar coordinate system. Okay, so coordinates system. So that in this time, definitely you have the same r and theta, right? And then we have a z additional variable. So there is not really, changing for z. You're going to keep the same z variable for triple integral. And then don't forget the r here. Many people forgot when you're calculating. So here we have r to multiply. And then you can change the order, dr, d theta, dz. You can change the order of the integral, doesn't matter. You will get the same answer, right? So again, if you are taking the integral in terms of the radius, so that this is going to be the radius integral, this is going to be the integral theta integral, and the last one is the z variables integral. So we are doing the same thing, what we just did in long time ago. Convert from rectangular to polar in double integral. Here we are going to convert from rectangular of the three variable into cylindrical coordinate, converting to r, theta, and z. Okay, so that's what we are going to do, and then that's what we call triple integrals in cylindrical coordinates. Okay, so in the last video, we practiced how to take the triple integrals, right? We already practiced how to do that. So let's take a look at the example 1, because we now are going to convert whatever the x, y, z into the r, theta, z cylindrical coordinates. Sometimes this is much simpler when you're taking the integral. X, y, z might be so complicated equation. And then we know a couple facts. X second plus y second is r second. R means the radius, theta is the angle. So if you have a circle, usually the theta is going to be between 0 to 2 pi. So these are the given, notation we can use when you're converting to the cylindrical coordinates in triple integral. So we're going to utilize that back as well. So let's take a look at the example one. So we're going to literally practice how to convert from the rectangular to the cylindrical coordinate system. So here, as you see that, they want you to take the triple integral, correct? So I have a triple integral. In this time, it's already given the cylindrical, coordinate system because I don't see X, Y, Z rectangular coordinates, correct? So this is good. We already have a cylindrical coordinate system. Okay, so we don't need to convert anything. And then they have a specific, in cylindrical, they have a specific interval for each R, theta, and Z. So we have to utilize this given interval. So everything is very nice because you see that it's a given. So we can write the triple integral very simply. The function is a Z times R times sine theta. And at the end, we have R, dr, d theta, dz. So this is the order that what they want to do. Again, if you want to change the order, that's okay. But then you have to change the order of the interval for the integral so that anyway, you will get the same answer. So this is the given, right? So let's plugging in whatever the information. So first you need to define the z. So this is the first variable. Let me double check. Yeah, dr. So if you want to begin with the dr, you have to start with the dr. So r radius, that's from 0 to 2. Okay, and then you can go to the next one, theta 0, and they actually pi over 2. And then the last one, dz 0 to 4, right? So you can now take the triple integral and you will get the answer. But the step is you can set up the triple integral as the given, with the given information. So the evaluation, the calculation is pretty straightforward. We're going to do the inside first, right? So you can continue. What do you guys want to do? So you can continue the inside and middle and last. And I just want to confirm with you. Okay. Many people confuse, Professor Ben, should I have to really keep the dr, d theta, dz order? No, you can change it. Right. So you're going to have a z, r, sine theta, and r. If you want, you can begin with the dz, right? And then you can go to dr, d theta. The order doesn't matter. You will get the same answer. So if you begin with the dz, it's going to be 0 to 4. And then r, 0 to 2, right? And then theta at the end, 0 pi over 2. Doesn't matter which one you're going to do first, it's going to be the same answer. So I just want to emphasize on that one more time. So you can begin with the dr or you can begin with the dz. It doesn't matter. I'm going to do the blue one, right? So it doesn't matter. You can, begin with the left side or right side, but let's try to the right side. So this is with respect to the dz, z variable. So what happened? I'm going to increase the z and you have to divide it by that. So there's a couple steps, but let me just multiply r with the term next to each other. So this is going to be z r squared sine theta dz, right? So since we are taking the integral with respect to z, r and theta, that's a constant. So therefore, r second sine theta, z to the second, then divided by 2 from 0 to 4. Again, you're going to subtract from 4 to 0, and then this is a z, so I'm going to plug in 4 into z. So r second sine theta, nothing changed, 16 over 2 minus 0. So everything is a 0, so I don't need to write that. So that's going to be 0. So we can calculate it, 8 r to the second sine theta. So this is the first part. And I'm going to keep on going because I need more space. You're going to do 0 to 2, 8 r second sine theta. And now we are taking the dr, right? With respect to r. So in this time, 8 sine theta, that's a constant, r to the third 3 from 0 to 2. So you can calculate that information, right? So if you do that, what happened? I'm gonna do 8 over 3 sine theta, and then 2 to the third, and whatever it's gonna be 0, right? Or if you confused, I can rewrite it for you. 8 sine theta, 2 to the third over 3 and minus 0, that's whatever. We don't need to consider. And then this is 8 sine theta, 2 to the third, 8 over 3. So 64 over 3 sine theta. So finally, we're going to go back to the last one. 0 pi over 2, 64 over 3 sine theta. So, oopsie, there's a d theta. So 64 over 3, just the number. And then you're going to take the derivative of the sine theta. What is it? Derivative of sine. It's going to be cosine, but positive. So cosine theta from 0 to pi over 2. There we go. Almost done. So what happened? Subtract 64 over 3. Cosine pi over 2. 64 over 3. Cosine 0. So you can go to decimal. What is a cosine pi over 2? So you can type cosine pi over 2. That should be negative 1 over 2. And cosine 0 is 1. So if you calculate it, I got negative 32 over 3 minus 64 over 3. So you can simplify that answer. So if I calculate that information, let me double check. Cosine 0 is 1, 64 over 3, and then 64 over 3 times the cosine pi over 2. It's a negative 1 over 2. So I have a negative 32 over 3 minus. So what you're gonna get? I'm going to get negative, what is it, 32 minus the 64? 64, 32, 96 over 3. So negative 32. So my calculation hopefully correct. So let me double check. We had a sine. So let me double check. The integral of the cosine is a sine is a positive cosine or a negative cosine? I think there's my mistake. Integral sine is a negative cosine. So sorry about that. I'm going to get rid of it because there's a little bit of typo. So I'm going to get rid of this part because I miscalculated. This is going to be negative. When you take the integral sine theta, this is negative cosine theta. Derivative of sine theta, it's positive cosine theta. So there's a mistake, so it should be negative. So one more time, then negative 64 over 3 cosine theta pi over 2, 0. Am I correct? So now you can finish up. So negative 64 over 3 cosine pi over 2 minus 64 over 3 cosine 0. There we go. So negative 64 over 3 pi over 2 cosine is a negative 1 over 2. Go to decimal. And then double negative change to positive. And this is 1. So therefore, I got double change to positive. So 32 over 6, actually 3, because I divided by 2. Plus 64 over 3. Am I correct? My calculation is better now. So if you do that work, that should be 96 over 3, positive 32. I think that should be the answer. So let me hold up here. double check, okay, if I have anything. I think that should be clear, okay? All right, so check it out. So this is a simply like same idea, taking
Excuse me.
Yes.
Cosine pi over 2 equals what?
Negative 1/2. Let me double check. You can check with the calculator as well. Cosine.
In my calculator equal to 0.
Oh yes. Thank you for confirming that. So that's actually 0. Sorry about that. So what I'm saying is go to decimal. And then I'm just looking for, I don't know where the negative 1/2 came from, but it's cosine. We have pi over 2. So it should be 0. Yes. So my mistake. So that was a 0. So if I complete that, negative 64/3 times a 0, and this is a 0 anyway. So 64/3, that's actually the answer. 64/3, we cannot simplify. So I'm just checking the answer. This is a textbook question, so we have the same answer. So I just utilized the right side, right? So what I'm saying is if you do the left side, you should get the same answer. So check by yourself. You should get 64/3. Okay, so this is how we are taking triple integral over the cylindrical coordinate system. Sounds okay? So far I haven't shown you how to convert from whatever rectangular XYZ into R theta Z. So let's take a look at that example. Okay, so if you guys okay, I'm gonna go down slowly the example 2. All right, let's take a look at example 2. Everybody okay with that? I'm gonna go down. Yep, so this is exactly, we need to take the triple integral. So as you see that, this is what? Rectangular coordinates. I mean, you can use a rectangular coordinate system, but take a look at it. Like this radical is bugging me. And then if you convert it to the cylindrical coordinate system, because we have a 3 variable x, y, z coordinate, we know that x second plus y second will be r to the second. So when you convert x, y in terms of the r second, that's going to be something simpler, isn't it? So we're going to convert the rectangular into the cylindrical coordinate because we are dealing with x, y, z, right? Because we have a 3. It's not just x, y. It's not double. It's a triple. So let's step by step. We need to find all the interval for r, theta, and z. So let me find out. Okay, so we're gonna find out the where e, because f, we're gonna convert this one, r theta z, correct? So this is what we're gonna convert. So r theta z, I'm gonna find out the interval for each r theta z. First of all, the easy one, we can find out theta. Theta is going to be 0 to 2 pi. And obviously, this is a circle, half circle equation. So yep, circle, the total area should be up to 2 pi. So that's so obvious. And then we can convert something. So here, I'm going to modify z equal to, you can think about it. So first of all, we already know z. We already know what the theta. And then what we can do, you could do the inside, the function is going to be x second plus y second is r to the second. So this is going to be r. So this one, this rectangular, you're going to take the r dv. That's actually, you're going to convert it. So this one is the same as r. And then I need to still find out the some, theta. You have to find out the z interval. You have to find out the the R, interval. So that's something we need to continue to think. So let me think about it. So first of all, this is the Z, right? And then you can think about it. Z equal to 9 minus x second y second. That means if you factor negative x second plus y second, 9 minus r to the second. So this is your interval for Z. Z is going to be from 0 to 9 minus r to the second. That's it. That's the Z interval. So in this interval, your information gonna be only include r theta Z. So that's good. And then now we found out the Z. Z is going to be explained by the R variable. And then R variable, we need to think about it. Now, let's say you're going to use this one to find out the R interval. What we can do. So here, since the Z is going to be, this interval, now you're going to just get rid of the Z. So 0 equal to 9 minus x second, y second. So we already know that this is going to be positive x second, y second is 9. So this is exactly circle equation. And then in the circle, this is the r second. So r is going to be plus minus 3, isn't it? So it's going to be -3, +3. So you have to really think about how to find out the interval for r, theta, and z. So I just show you, I'm not doing any special work. I'm just using the fact x squared, y squared equal to r squared. So we know theta begin with the theta. It's between 0 to 2 pi. And then z you can find out from here. And then get rid of z. And then whatever the rest of thing we're going to use for you're going to find out the interval for r. So that x second plus y second equal to 9. That's a circle equation, which means the radius is plus minus 3. So your radius should be from -2 to 3. That's it. So that's something you need to catch up. Now take the triple, triple, triple. So we already convert this, rectangular to the R, right? And then now it's up to you. You can begin with the Z or you can begin with the R. Theta doesn't matter the order. I'm going to use dz, dr, d theta. So then write down the interval for each one. So Z is a 0, 9 minus r second, r, -3, +3, theta, 0 to 2 pi. So setting up the equation, it's not that complicated. So the rest of work, you can try that. So I'm going to try a little bit. So let me bring here. So then this part, I don't have, r is a constant. So r, z from 0, 9 minus r second. So r times 9 minus r to the second. And minus 0 is 0. So that means -3, 3, r, 9 minus r second, now dr. You can actually expand 9r minus r to the third, dr. So now you can take the integral, 9r to the second over 2, r to the 4 over 4, so -3, 3. So I'm going to make a little bit of space. So here, 9, 3 second over 2, 3 to the 4 over 4, subtract 9 minus 3, 9 minus 3 to the second over 2, minus 3 to the 4 over 4. So calculate it, what you're gonna get. If you feel like this is complicated, just go to decimal and type it. So I'm gonna use decimal, 9 times 9, divided by 2 minus 81, that's 8 to the 3 to the 4 divided by 4. So this one minus entire, the next one, 9 minus 9 times -3 to the -3 to the second divided by 2 and minus -3 to the 4 4 divided by 4. So if you calculate it, I got 81. What you got? So I literally type those equations. So this one should be 81. Okay, that's good. Am I correct? And then you're gonna keep on going. This is 81. And then what? We're gonna do the last one, 0 to 2 pi. 81 d theta. So 81 2 pi minus 0. So you should get 162 pi. Let me double check if I have any mistake. So I have a 9r and minus r to the second. Oh. 1 second. Is there any mistake that I have? Yes. Did you guys notice something? Is there my mistake? So this r from here, right? But according to the formula, you are supposed to multiply extra r. That's what I didn't do it. Dun. Sorry. So we have another r there. So that's my mistake. So we have to do a little bit of work. So actually, this is r to the second. And then you're gonna do the rest of work. So let me just, quickly edit this part. So we have r times r to the second. That's anyway constant when you're taking the integral with respect to z. So r to the second z, that's good. And just this part, we're gonna get here 9 r to the second minus r to the 4. That's my mistake, right? So when you take the integral, it should be 9 r to the third over 3, r to the fifth over 5 from -3 and 3. Actually, that's something you need to do because there's extra r. So this part, we have to just modify. And then this part. So if you just recalculate that part, this is 9 times 3 to the third divided by 3, 3 to the fifth divided by 5, minus -3 to the third, 3, -3 to the fifth over 5. So let me just double calculate that part with the decimal. So 27, 3 to the 3 to the fifth divided by, this is a 3, this is a 5. You can use a decimal as well. And then that should be to the third, right? And then divided by 3. And then -3 to the fifth. Oh no, I just get rid of it. Sorry, 1 second. So -3 to the 5 and divided by 5. Okay, so what you got? Anybody got the answer? So I got very, 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 very ugly number, 64.8. So let me double check. What you gonna get? So 3r to the third, r to the fifth. So 3 to the 0. But okay, I think a little bit of mess up, guys. So let me just get rid of it. This part, because I'm gonna calculate again. I just wanna make sure something. I wanna make sure one thing. So this one. So this part, that's how we got the all the integral. Do you remember that? Because I'm also, I might be making a mistake, but I just want to review one more time. So theta is a 0 to 2 pi. 0 is a clear. Oh, I see what's going on over there. So as I mentioned, the radius is going to be only positive number. Nobody can say the radius, you have x second plus y second equal to 9. Radius is a 3, not -3. No matter which radius you go, it's a +3. It cannot be negative number. So that's why I made a big mistake here. Here, from 0 to 3. This is not -3 to 3. So that's my mistake. So I'm going to highlight all my mistake. So this is something we need to be careful. Radius should be a positive number. That's what we forgot, right? And then what else? The extra R, that one. So that's something we need to modify. So we actually did a good job so far. Just changing -3 here. 0, right? So this is going to be 0, 0, and it's going to be easier number. So sorry, we got this one, but we are making better. So now you are able to fix the mistake. So let's continue from here. This is a cancel. So 3r to the third minus 1/5 r to the fifth 0 to 3. That's actually what we need to simplify. This is a middle. This is a first integral, second integral so far. So that's going to be 0. So 3 third 1/5 3 to the fifth, whatever 0. So yeah, we just need to calculate that part. So let me recalculate that one. So 3 times 27, that's 81. Minus, you're going to divide it by 3 to the fifth. 3 to the fifth divided by 5. So that's going to be 32.4. So this is a second integral. Now we're going to go back to the last integral, 0 to 2 pi. 32.4 d theta. So that this is constant, 32.4 theta, 0 to 2 pi. So 32.4 times 2 pi minus 0. So it should be 64.4 pi. Yep, that's the answer. So now it's getting better and better. Okay, so I double checked the answer. Yeah, this is your final answer. So I'm going to show you entire work. So as I mentioned, yep, we may be making a mistake. That's okay. Just go back. We need to clarify something. Radius should be positive number. There's an extra x. At the beginning, we just ignore them. And then I just modified that again. And then you can find out the better answer. So that's the answer for number 2. So I'm going to hold up here. Does it make sense to you? So you can double check yourself. My answer is correct or not, but it should be correct. So we are keep utilizing the technique of integral, triple integral. Just you need to define the interval for each, variable. You're going to have a total 3 different variable for triple integral. So that in this time, x second plus y second, I don't know how to find out the interval for x, y, z. So in this time, we convert it to cylindrical coordinate such that r, theta, z, so that it's easier to find out the interval for theta, interval for z, because it's a given right there. And then it's easy to find out the r radius because it's a hard circle equation. So by utilizing that cylindrical coordinate, you can finish up the triple integral. So I'm going to hold up here. Sorry, there were a couple of mistakes, but we got it now. So how you feel? So if you got this one, can you show me your thumbs up? Does it make sense to you, everyone? So definitely, you need to download my lecture note or study with them anytime, anywhere. Just go over. I'm not doing something new all the time. Whatever the concept we are dealing in every video, you learn it. We already learned double integral, we already learned how to find out the interval for each variable. We are just expanding the knowledge from 2 variable to 3 variable. That's why from double to triple. And then if you understood how to convert from rectangular to polar coordinate, same thing here, from rectangular to cylindrical. Just we are working with the additional variable, additional integral. And then just be careful when you really define the interval. That's where many people mistake, like what I did, right? So anyway, I think I show you 2 examples how to take the triple integral in terms of the cylindrical coordinate. I'm not giving you any confusion. It's a very simple concept. Just calculation looks ugly, okay? So you don't need to scare off anything, okay? Just get the organize the concept. Concept is pretty simple, okay? All right, I'm gonna continue the next one. I'm not gonna do this one, so you can think about it. So that's why, you see that? If you are dealing with the rectangular, right, coordinate system, look at that. This is a so complicated interval. We don't like it. We don't like it. I want to convert this one, the cylindrical coordinate system, right? That's what we are doing. So you don't need to actually calculate this one. So if now they're giving you more example, you can convert it to this one R, and then you can take the triple integral in an efficient way. Because this is, as you see, it looks complicated, taking triple integral with the rectangular. Nobody wants to do that, right? So if you are converting to the cylindrical, the interval is gonna be simple. You see that? So that's why I suggest to you to convert from rectangular to polar or rectangular to cylindrical coordinate system when you're dealing with the 3-dimensional space, okay? So this one, I'm just give you the idea. Ooh, look at that, it's complicated. So convert cylindrical coordinate is much helpful. So to solve this question, actually, we need more given information. So then like what I did, you need more given information, like Z equation or whatever other equation should be given. So they didn't give us not a lot, so just be aware. Converting to cylindrical or polar is much helpful. So that's something I want to emphasize one more time. So for the rest of slide, I'm going to practice. I'm not going to really solve entire taking integral. I'm going to just set up the equation. So let's read this. So consider the region E, the right circular cylinder with equation R equal to 2 times sine theta, bounded, and then the theta is going to be between 0 to pi, bounded below by the R times the theta plane, and bounded above by the sphere with radius 4 centered at the sphere, at the origin. So as you see that, there's 2 different geometric shape. One is a cylinder, circular cylinder, this one. Another one is a whole sphere. And they said the sphere has a center 4 so that you can find out 4,00 on the x-axis, 0,4,0 on the y-axis, 0,0, y on the z-axis, because the center 4 for the sphere shape. And then they say the cylinder is inside, okay? So bounded below by the R times R theta plane, and bounded above a little bit in this of the sphere shape. So that's what actually they're describing. That's where they're located. And then they want to find out something. Let's take a look at it. Set up a triple integral over the region with the function R theta Z in cylindrical coordinate system. Okay, so it looks like they want to find out the region that are surrounded by the cylinder and that are also surrounded by the sphere. So something like intersected between those 2 different shapes. It's hard to see, so that's why I highlighted a little bit of a red color. So we are looking for that area between. bounded below and above inside of the sphere. They are where, overlap with this cylinder area. So something we are looking for is the intersected area between those two shapes. So they want you to take the triple integral to find out that area. So let's look at that image. We have a couple more. So the radius of the cylinder is 2 times the sine theta. And then, okay, this is great. This is a sphere equation. R second plus Z second equal to 16. So let me write it. There is sphere equation, R second, Z second is 16. And then by looking at this equation, we might be able to find out the interval for Z. Okay, so let me think about it. I'm gonna just solve for Z, right? So that Z second equal to 16 minus R second. And then Z equal to radius 16 minus R second, because I want to get rid of the second part. So this is the Z from 0 to 16 minus R second. So what that means is the interval for Z is changing, right? Depending on the R variable. So now we need to think about the R variable right there. So we don't need to consider this R because that's a large. We are looking for this region. So that R is going to be your interval. So R is going to be changing between 0 to 2 times the sine theta. And then theta is the last one. They say from 0 to pi. Okay, so now I set it up. The area, the interval for R theta Z. We have all the information, so I can write it. Theta is going to be 0 to pi. And the radius is between 0 to 2 times the sine theta. Okay, the last one, just I need a space. The Z, 0, 16 minus R second. So there's no X, Y, Z. This is literally coordinates, cylindrical coordinate system. So now you can set up the triple integral. So now the formula, we don't know the function. So the R theta, just write down all the information. So I'm gonna write dz, dr, d theta. And then we're gonna write down the interval for Z, 0 to 16 minus R second. R, 0, 2 times the sine theta. Theta, 0 to pi. So we don't know the equation of this cylinder, so that's okay. They are not asking you to solve the, taking the triple integral. Just set up the equation. So this is your answer. And then don't forget the R. So this is going to be given. Then you're going to plugging in and find out. So the equation will be given like F R theta Z equal to something. So they didn't give us. Then you can continue. But here, just with the random function, so we just write it F of R theta Z. So that's the answer. So this is how you're going to set it up. Okay. All right. So we are keep practicing it, setting up the equation with the triple integral, and then setting up the interval for each theta, R, and Z. That's it. Okay, nothing is special. For example, on the final, I might be just asking you, set up the triple integral by defining the correct interval. I might not be asking you really taking unless I'm giving you the simple equation, but like I might not be asking you really taking the triple. Like this is like, you can try, but it's a lot of, this one you can see in the final because the number was not that crazy. I'm not going to put that kind of question on the final. Nope. But like I might be asking you, set up the triple integral with the given information. Okay. So we don't need to continue, just stop there. That's it. Okay. So likewise, I'm gonna just do one more example. Nothing is a special. We are doing awesome, okay? So are you guys okay so far? I just wanna make sure. So all the question that I'm dealing with from the textbook, so you can find out the same answer, more detailed solution, but I'm just trying to explain in a more abstract, easier way, because the textbook explain a lot. But anyway, my key point here, define the correct interval. That's important, right? All right, so if you guys, okay, can we practice one more? Can you guys show me your invisible thumbs up? Are you guys okay so far? So let's take a look at one more. So here, same thing. I'm not gonna solve, I'm gonna set up a triple integral. Good, good, good. Okay, thank you, thank you. And then they said, this is the Z. So that let E be the region bounded below by the cone shape. So now just they're dealing with the geometric shape, which is a cone shape. And then there's a cone shape, and there's a parabola shape. Two things are going on, okay? And then they want to find out the region bounded below by the cone and above by the parabola shape. Something like, you know, above the parabola, and then what? Below the cone shape. So it's hard to like shade it because this is a three-dimensional shape. So I feel like they're talking about a little bit outside of the cone, like outside of the, you know, sphere, the inside of the outside of the cone shape. But it's not really important where we're gonna shade it, because we just need to understand how to define the integral for x, y, r theta in z. Okay, so hold up there. Let me just think about it. We have a couple equations. So this is the equation for the cone. This is the equation for the parabola shape. Everything is in three-dimensional space of cone and parabola. And then they're looking for kind of like intersected area between them. You can think about that way. It's hard to see, right? Because we are not really thinking, you know, operating three-dimensional way. You can think about like a below or, you know, above. You can think about like intersected area between two. It's not really important where you're gonna shade it, but here are two different geometric shapes. We are going to find out the volume that they're looking for by taking the triple integral, okay? So 1 second, we need to find out something, and plus they want you to, yeah, definitely, we're gonna convert it to the cylindrical because XY is complicated. The rectangular is complicated. And then they say want to find out the volume. Okay, the order should be dz, dr, d theta. Okay, they define which one you have to do it. Okay, so step-by-step work. We need to find out the region for r theta z, and then that means definitely we're gonna find out the theta interval, and then you're gonna find out the radius interval, and then we're gonna find out the z interval. Right, we're gonna do this work. This is important beginning part. First of all, they're dealing with the cone shape. There's a circle. So theta, I told you, most likely it's going to be between 0 to 2 pi because up to 360. Okay, so that's clear. Theta is not that easy, not that difficult to find out. And the radius, that's something we're going to do. I'm going to think about it. So this one, we have two equations, z equal to x second, y second. That is the same as r to the second. Why? Because x second, y second is the same as r second. So that means z equal to r, right? So something we found out that information. In the second, z equal to 2 minus x second minus y second. And I'm going to actually plus because I'm factor out negative. So 2 minus r to the second. So here we have z equal to 2 minus r to the second. Are we okay? All right. So now what we're going to do. Thank you, Yuan. Maybe, yeah, you are correct to describe the area. So we are looking for, so I will explain to them. Maybe my graph is not correct. But anyway, let me finish up to find out the integral first. Thank you. So we found out two things, z equal to r, and then z equal to 2 minus r second. So we have a 2z, they are equal to each other. So what does it mean here? This one and here, we can say r equal to 2 minus r to the second, because I want to find out the interval for r or theta or z. So here I'm going to solve for r second plus r minus 2 equal to 0. Are you guys following what I'm doing here? I'm not creating anything, something new. So x second plus y second equal to r second. From first equation, I found out z equal to r. And then second equation, z equal to 2 minus x second plus y second. We got z equal to 2 minus r second. So that means both of them z. So r is equal to 2 minus r second. Oh, we can find out the factor. R minus positive 2 minus 1. So that means r equal to negative 2, r equal to 1. Wait, what did I say? R cannot be negative number. Radius cannot be negative number. So we got it. R equal to 1. So between 0 and 1. That's it. Are you following? So we are doing better and better. The older thing we need to do, the z interval. So the z interval right there from R2. So we have all the information for z. R2, 2 minus r second power here and here. That's for z. So we have all the intervals. So all you need to do, all you need is, I know that song. So anyway, we can finish up the full integral equation, set it up. So honestly, they didn't give us any, what the f, r, theta, z, they didn't give us. So you can keep it or you don't need to write it because they didn't give us. But I'm going to just keep it. And then don't forget the extra r. And then we are using the order dz right there, dr, d theta, and plugging in all the information we found out. So it is going to be, what is that? For the z, r 2 minus r second, and dr 0 to 1 and 0 to 2 pi. So whenever the f function is given, then you can calculate it. But we don't need to calculate. We're going to just stop here because they want you to only set up the triple integral. So that should be the answer. So make sure the radius cannot be negative. So that's where we made a mistake at the beginning. So when you find out negative 21, get rid of negative, only positive. So this is the interval that you got. So that's how you set up that equation. And I just want to share one thing. I think Yulin attached the image. I think maybe your file, your image might be better to describe this information. So the textbook or my image might have a little bit unclear image. So what they're saying is above the, so below the corn, above the parabola shape. So it's a little bit upward, bounded when I look at the image. So that's okay, because we are not really, drawing that image. So all you need to do in this chapter, defining the correct image. And as long as you can understand how to set up the triple integral with the given cylindrical coordinate, it should be fine, okay? So don't worry about the image part because all the information should be given in the context, okay? So just be aware. So that's number 2. We just set it up. We just set it up the triple integral in terms of the cylindrical coordinate. There's no x, y, z. All right, are you guys okay with that? So I'm gonna just hold up here. So no worry, I'm not asking you to solve that, taking triple integral, unless we have an easy, equation you can try. But in this time, we're just using, setting up the equation. Okay, are you guys okay? Can you show me your thumbs up? You guys okay? So if you got this one, I'm gonna do just one more example, last example. So here we go, one more time, try it. So same context, something going on, two shape, okay? And then we have a two different, equation for one geometric shape, another. So in this time, we are having what? Parabola, half, kind of like a half sphere. And then we have like a cylindrical shape inside. So that's the equation one. This one looks like, let's see. This is the, cylindrical shape. And this is the kind of like a half parabola, half a sphere equation. That's okay, that's a given, that's a great, because we're gonna use them to find out the interval for, we are going to find out the interval for R theta Z. So step by step, don't rush. So here, so we are going to set up the triple integral in terms of the cylindrical coordinate system to find out the volume of the region using the following orders, dz, dr, d theta. So we're going to use that order. Okay, step by step. What can we do first? I can do, because your goal is changing xyz into r theta z, right? Because we want to convert. So this one, we are going to, whatever xyz, we're going to convert it to the cylindrical coordinate. So we have x second, y second, z second equal to 4. I can convert it this one, r second, z second equal to 4. So then you can leave it there for now. And then another equation is here. X second, y second is 1. That means r second is 1. So you can find out the radius plus minus 1. But we are not going to use negative, so r equal to positive 1. So we already know the interval here, r theta z. Obviously, theta is going to be between 0 to 2 pi, unless the context is changing that information. Usually it's 0 to 2 pi. And then we have a radius just found out, 0 to 1, right? And then all you need to do is a z now. So you can find out the z interval from the first equation. So here, let me just minimize it. R z square equal to 4 minus r square. Z equal to radical 4 minus r square. So from 0, 4 minus z, r square. So everything is in terms of r, theta, in z. So we got that. This is your interval. We got it. And then setting up the equation. That's the next spot. So you are going to do what? Triple, 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 r theta z. So I don't know what they're giving us. They didn't give us what it is. So that's okay. But don't forget the r. Okay. So usually there's a many, example. If you remember in the last time, if you don't have the given equation for r theta z or r theta, you actually begin with the 1. Do you remember the volume is a 1 total, and then you're looking for how much they're filling up by looking at the interval. So it's okay. So I'm gonna actually later change it, but this is okay too. So we are going to dz, dr, d theta, and then plugging in the interval. So the z 0, radical 4 minus r second, dr 0 to 1, theta 0 to 2 pi. So this is a triple equation. But what I'm saying is, addition, this is going to be equal. Okay, I'm gonna let me just copy this. Oh no. So this one, if I copy, paste, what I'm saying is, if you remember in the triple integral, if the function is not given, you can assume, right? There is a 1. You're going to begin with that. So therefore, although you don't have the given what the function for r theta z, you can actually just begin with the 1. Then actually you can calculate it, by taking the integral with respect to z first, r and theta. So that's actually, you can find out the answer at the end. But since they're just asking you to set up the triple integral, I can stop here, but both of them is the same meaning. Okay? Unless they're giving you the function, if they don't give us, usually you're going to begin with the 1. Do you remember? Same thing here. If this equation, it's the same as 1. You can begin with the 1. And then actually then you can calculate it. Okay? So just be aware, even though you are writing this one, it's still the answer because they're asking you, not calculating. We are not supposed to calculate, just ask you to set it up. So either this one or that one is the same answer, but what I'm saying is you can actually calculate it if you consider this is equal to 1. This is equal to 1. So you can actually evaluate the volume. Okay? So that's what it is. I think we finished, this is a 5.5, triple integral in cylindrical coordinate. We are not going to focus on spherical, the cylindrical shape. So that should be enough 5.5. How you feel? 5.5, it's not really crazy work. Just that we are accumulating the concept over your previous knowledge, okay? So I don't think that we're gonna move on 5.6 today. It's 5.6 is obviously same thing from calculus 2, how to find out the center of mass and moment, but I will talk about it in 3-dimensional space in the next video. But 5.5, I think we conquered everything. So I've been showing you a couple examples how to find out the integral more clearly, and then how to set up the triple integral. And then if you need, you can calculate it by considering the f of r theta z as a 1, because we are looking for the volume, right? So these are all the practice. So we've been focusing on today how to convert the rectangular to the cylindrical, like we did in the double integral from rectangular to polar. So that's all about it, 5.5. So now you guys can finish up 5.5 quiz. There's only 3 questions, 2 or 3 questions should be fine. And also their embedded video. I hope this video is practical and helpful. I will see you guys in the next video. I will do 5.6 and it's gonna be